Hi. So this is the last screencast of our unit on energy resources. It's going to be about energy conservation. And just take a look at this picture. I mean, I think this just says it all. So basically, if we can increase the efficiency of our systems, then we can decrease the amount of energy that we're consuming. And this has two benefits, right? It means that we're going to put less carbon dioxide in the atmosphere and we're going to extend our energy resources. And that's really what the idea is. Okay. So conservation is a pretty simple way of making changes that extend our resources. So, we look at this graph that we had before. So this is basically peak natural gas, peak gasoline, peak coal. These curves are not absolute; they can be changed. So if we have better efficiency technology, we can extend these out further, giving us more breathing space in which to come up with alternative plans. So, all that doom and gloom I've given you, it can be circumvented to a certain degree by improving uh, our um, our conservation. So basically, conservation comes down to basically you can change personal habits yourself that cause you to use less energy. And the other thing is we can improve energy efficiency through technological innovation. And that's certainly something that is happening quite a bit and will hopefully continue to happen. So let's just look at the ones that you're expected to know about. First of all, how do you change your habits? So look, I'm wearing a fleece. You can wear a sweater. You can basically change your mental thought about what it's like to be in your indoor environment and say, look, I'm just going to keep my house a little bit cooler in the wintertime there. Otherwise, what, 'cause I can always put a sweater. That's a little bit more difficult in the summertime because there's really nothing you can do to really make yourself less hot. But you can also make yourself warmer by putting on more clothes in the wintertime. You can basically just make a point of, I'm going to turn off lights when I leave the room. I'm going to turn off the TV when I'm not in the room. Another thing you can do is you can choose to use public transportation rather than drive a car. I mean, this is a huge amount of our energy resources completely wasted on people's decision to say, I want to have the convenience of setting my own schedule and using a car instead of public transportation. Public transportation uses a lot less energy per person. But people tend not to do what they're supposed to do. It's just too easy for all of us, and myself included, to make the right decision. So it really helps to have the government or some sort of agency say, "Look, here's what we're going to do. We're going to make your life a little bit more difficult if you don't do the right thing." So one of the best things you can do is a tiered energy billing system. They do this in Korea. They don't do it in America, but they do it here. But the idea is like, hey, if you're allowed to use so much energy, but if you use beyond that, we're gonna dramatically increase what we charge you per kilowatt hour. And if you go beyond that, we're really gonna ding you, right? And so we make it an economic incentive to not use so much energy. But this basically it doesn't work unless you get some sort of real time feedback, which really isn't built in the system yet. But if you could look at a a monitor in your house and say, "Hey, you've used this much electricity, you've got this much more to go," and then you're going to start paying more, you would start to conserve more. You can increase taxes on gasoline. Gasoline in the United States is so cheap compared to other countries because people don't like paying taxes. But you put taxes on gasoline, people will start looking at it going, maybe I will take the train instead of taking my car. So it definitely motivates people to conserve. You can raise tolls on roads so that it costs more to drive your car, and you can also just make it so that public transportation costs less. So all these things together basically gives people a personal economic motive to conserve energy, and that's good for all of us. The other thing you can do is you can just improve technologies. Okay, so let's just look at a couple examples of this that you're expected to know on the AP test. So first of all, is lighting. A lot of the energy budget for your house comes to having artificial light in your house, right? Well, LED lights are so much more energy efficient. So I grew up with incandescent lights. 60-watt lights produce about 100 lumens of light. We often use like 100-watt lights, okay? But let's just look at this. You get the same amount of light, 800 lumens, by using 12 watts of LED light. So that's basically 5 times less energy, right? So your energy goes 5 times further. You're using 5 times less carbon dioxide. It's amazing, right? It's just technology. Um, Smart home systems. We have the technology now. We just don't deploy it as much. But governments can encourage us to do this or provide us with subsidies to do this. You can have systems that know if you're in a room or not. And if you're in the room, we leave the lights on, we leave the TV on. But as soon as you leave that room, or after a certain amount of time, we go, hey, there's no one in the room. Let's turn off the lights. Let's turn on the TV. If you scale this over an entire society, there's huge energy savings. That means hugely extending the length of time that our coal and natural gas supplies are going to last, and reduce the rate at which we're destroying the atmospheric carbon dioxide. You can also have things like smart glass. It's a little bit more expensive, but things that basically, they LEDs that they change colors so that you let less light in the summertime and more light in the winter. There's lots of innovations like this that we can deploy that are designed to reduce energy consumption. Now, one of the big ones, and one that they definitely would like to ask you about on the test, is electric vehicles. This is a huge change. Okay, so the idea is an internal combustion engine. You're basically you're burning gasoline here, and it gets really hot. They have efficiency that's terrible, like 10%, 15% efficiency. Think about that. 85 to 90% of the gasoline that goes into a car just goes to making it hot, not to making it go. That's just stupid. All right. So what makes EV cars better? Okay. So first of all, the engine's not getting hot. Like when you plug it in, the battery does get warm, so there is some waste heat there, but not nearly as much. And here's a really great one: when you put your foot on the brakes in a regular car, what happens is those brake pad, the calipers come together, and basically the friction between the brake pad and the brakes basically just generates a lot of heat. So you're taking the kinetic energy of the car and turning it into heat in order to slow the car down. But when you do that with an EV vehicle, most of the energy instead is just going to run the electric motor backwards, turning it into a generator and just recharging the battery. So you're basically, instead of throwing away energy when you put the foot on the brakes, you're just putting it back into your battery. It is worth noting, though, and I don't know if College Board is very honest about this, but I want to be honest about this. Look, electric cars do not get us around the carbon dioxide problem that we're going to be talking about next unit, because you still have to make the electricity, which means you have to burn coal. So yeah, your car may not be emitting carbon dioxide or NOx or anything like that, but in order to put electricity in your car, we had to do that somewhere else. So the real advantage of EV vehicles is not their lack of emissions, which most people think about. It's really their improved efficiencies. Hydrogen technology, same thing. So, like hydrogen technology, it's not nearly as far as along. I mean, some people have them, but there's not as much infrastructure to support it. There's lots of charging stations for electric vehicles. There's not that many pumping stations for hydrogen, although there are some in the Seoul area. But let's just talk about it. A hydrogen fuel cell, which we talked about in the other screencast. Basically, it allows you to essentially uh, uh, like release the energy from a fuel without combustion. So the problem with combustion is that high heat that's generated is very wasteful. So here you're extracting your energy a lot more efficiently, but you're still basically turning fuel into carbon dioxide. You're just doing it without generating as much heat. So that greatly improves the efficiency of energy consumption. But again, they still produce CO2 because you're still converting a fossil fuel into carbon dioxide and water. You're just doing it in a non-combustive way. You're doing it using these membrane cells to basically use electron transport instead of just regular chemical reaction. So let's just look at the efficiency. So an electric vehicle has, now this is American data, so I'll just use this, has a gas mileage equivalent, or an MPGE, miles per gallon equivalent, of 160. That means, like, if it was gasoline, you go 160 miles on 1 gallon of gasoline. That's the equivalent of what you got here, right? And how far can they go? Well, they can go about 350 miles, and then you've got to recharge it, which is a problem because it can take a while to recharge. Now, if we could develop either fast recharging batteries or swappable batteries, so you go in there and the charging station just says, "Hey, here's a new battery. We're going to slide it into your car, and you're ready to go." That, I think that's where we're going to end up going. Well, let's look at hydrogen cars. Again, I'm not so sold on the idea that hydrogen is going to become a thing, but if it does, you have about 70 mpge, all right, which is less than half of what an electric car has, and the range is significantly less. But you're using fuel that's easier to come. Well, that's not true. Hydrogen is a little bit harder to come by, so I don't think that's going to be quite as much of a thing. And then we just look at gasoline. It was terrible. Gasoline, like I said, has like 10-15% efficiency, so you only get about 25 miles per gallon. A lot of them get less than that. These big SUVs you see in America, they have pretty good ranges. The infrastructure for recharging, for refueling them, is everywhere, obviously. So that's already a done deal. But just looking at it, the infrastructure for recharging vehicles is definitely in place, and it seems like EVs are the future, and that's good because look at that. I mean, look how many times. Like, no, I can't do the math. So it's like wait, 5, 6 times more energy efficient. Okay, hey, that's it. Thanks for watching.